Okay, hello, welcome everyone. I hope you were not waiting for a long time. So, I hope all of you already know whoever was waiting that today's session's topic is probability. So, I think many of you will be very exciting because I know probability is something which you think that it is very easy. And I tell you, it is very scoring. Just just something which is left in you, which is like because of which you are not able to do the questions. That is because of the basics. If your basics are not clear, then only the probability questions get stuck. Okay, like otherwise there is no chance that you are going to miss any probability question. Okay, so good evening guys, and for anyone, good afternoon, good evening, whatever. So Abhishek Kushwa is saying good evening ma'am. Good evening Abhishek. So first of all, I would like to ask all of you guys, how's the quality of our broadcast going on? So you can just rate it out of 10, 10 for the best and 1 for the worst. Okay, so you can just rate it out and we can just know that how was the quality and how you guys enjoying our session or not. And I hope you are taking the help of our PDF materials, test PDFs and everything. And I hope this webinar is going to be very useful to you all. Okay, so assuming that you have rated the quality, now we move forward. So all of you, like, I just don't want to be someone who just gets started. I would like to ask all of you that how is the preparation for your exam going on? Okay, so for anyone who wants to tell that their preparation is going on, I can help you out and make it. Let's like try to make it to the third level. Okay, and for anyone who is obviously doing the third level, that is the very base level, good luck to you and kudos, and like you are going good, and I hope you kill your JEE. Okay, so assuming all of you are in the level of third or second and who are in the first, let's make it to the third level very very soon. Okay, so now telling about the subject mathematics, obviously, and about me, I'm a software developer. Okay, and what I'm doing here, it's like a hobby to me, like because from my childhood I love mathematics. So when I was given this opportunity, I was like, why to waste it? Let's just make use of it and enjoy. So obviously the main interest will lie in uh, software development. And what is the aim? The aim is to to provoke your thought process, and obviously think that you can do anything is possible, guys, and obviously it is. So for anyone who feels like they are not the one or they cannot make it to the JEE, just don't give up. Like hustle and stay hanging there, and one day you will kill your JEE. Okay, it's gonna come soon, and I hope we will be successful very soon. So telling about the course firstly before starting the session. So our course consists of these 90 plus classes. We have this convenient educational platform, and we have syllabus from JEE Experts. The syllabus is designed from JEE Experts, and whoever is facing any problem, they can also contact us, and we can design your syllabus, we can design your timetable even, that this is how you can follow, and this is how you can continue to work, and this is going to increase your efficiency. So whoever is facing any issue, they can just let us know, and we are already helping you, and we are going to try more to help you out. Okay, and what else, we have this doubt solving practice also, flipped classroom method. I hope you already know, we provide you the PDF material before every webinar, and after that webinar we give you the test PDF, so that you can just check it out, that how is your growth after that webinar. Okay, and that is it about our course, and I hope you will enjoy our course. This was the flipped classroom method, which I already told you in the first slide. So what we telling about more about the flipped classroom method, it is being followed in very big universities. Okay, in India also, in IIT Delhi, flipped classroom method is being followed, and even in Harvard University, it is being experimented that your efficiency increases following the flipped classroom methods. That is when you read the theory or study material before attending the class, before attending the webinar talking about this situation, and after that when you do the homework and do this homework check, that is the analysis of how you have grown in this topic, that increases your efficiency, that increases your knowledge of the topic. Okay, so flipped classroom method is something very beneficial to you, and whatever is beneficial to you, we are already doing that, we already want to do that. So this is what is about flipped classroom method, and I really advise all of you to follow it, guys, and because if anything is helping you out, if anything is increasing your efficiency, you should just go for it. Okay, so telling you about a subscription plan, see, there are three plans: light, smart and proficient. So whoever wants to be above average, they can follow this proficient plan. Whoever wants to be like, this is smart plan, this is okay. But whoever wants to be like more than that, they think that they have completed the course and they want something extra, they can go for the proficient plan. Okay, and for the, or for the average ones, they can go for the smart plans. You have all these things which are mentioned with the ticks and cross. You can just verify whatever you need and whatever you not, and according to your criteria you can just choose whichever plan you want to choose. Okay, so the topic is obviously probability, we have already told you. Also, my name Krishvi Srivastava, you can call me Krishvi. Okay, it's Krishvi. Okay, you can call me Krishvi, there's no issue. Okay, so let's move forward. So what is the need? Because the before starting any topic, you need to know what is the need of that topic. So obviously, in real life also, whenever you do anything, you have this tendency to find out that what is the probability of this thing, what is the probability of success in this thing, what is the probability of failure in this thing. So in real life situation, it also occurs, and obviously in mathematics, you have everything which is going to be possible. So for calculating the possibilities, because the world is full of possibilities, you need to calculate the possibility level. Okay, that if it is going to be success or if it is going to be failure. So obviously you know why you need probability. Like probability is something which is used, which is majorly used in your real life even. Okay, so whoever says that they don't need to study maths because of this real life situation, no, they are wrong. Okay, now telling about the representation, you know that we represent probability by this thing that we, for example, you have to find the probability of event E which has occurred, so you can just represent it like this. Okay, and now whatever probability you need, in the numerator it comes the favorable event. Okay, I will tell you about the event sample space also. And in this, the total events which is the sample space, you can also, in mathematic terms, it is known as the sample space. Okay, so this is known as the sample. Ashrita is saying hello, ma'am. Hello, Ashrita. I hope you are doing fine. So this is the probability formula, that is the favorable event upon total events. Okay, so now telling you about the event, telling you about the random experiment event. And thank you, Kushang. I have worked on my writing a lot. I have been scolded from my teachers a lot for my writing. So now I can write in such a way that people can read, thanks to my teacher. So the event, random experiment, these are some terms which are typically being used in your questions of probability, and you need to know about this. So whenever you come across these terms, you can't skip the question. You know these terms and you can simply go through that. Okay. Oh, sorry. Okay. Okay. Sample space. We have such terms like sample space. So what is sample space? Sample space, in set also we have this set of A, set of B, and we have universal set. Okay, universal set which consists of all the sets. Similarly, we have the sample space, the possibility of events, whatever events are possible, they come across sample space, and whatever it is, whatever probability we have to find, they come in the favorable event. Okay, so about the sample space, I hope this is clear to you all that what sample space means. Sample space means whatever event which is occurring. Okay. Now, uh, what else we have? Sample space we have done. I told you what is sample space. Event is something which which occurs. Whenever we are talking about something, that we are tossing a coin and you have to find the probability. So the tossing of a coin is known as the event. So that can be named as the probability, to calculate the probability of that event. So whatever thing which is being occurred, that is known as the event. Okay, now random experiment, the experiment which is about which you don't know the probability, that it can be very random, you don't know what is going to be the probability. So that is something which is known as the random experiment. So no, uh, how you can define it? You can define it as the outcome for which you don't know the result. Okay, so writing the definition of it, you can write it as an event or an experiment whose outcome cannot be predicted. Okay, so that is why you calculate the probabilities. Okay, So random experiment, an experiment whose outcome cannot be predicted. That is why we come across probabilities to calculate the favorable probability, to calculate if that event is going to occur, if that event is not going to occur. Okay. And now talking about more, we know some more terms as outcomes. Let's just write some more terms. So another term which we have is outcome. Okay. So whatever is the probability's outcome, whatever the event's outcome is known as, that is known as the outcomes. Okay. So how you can define it? You can define it as the result of an event. The result of a random experiment. Okay. The result of a random experiment, that is known as the outcome of that event. Okay. Now when we talk about the complementary event, we also have this complementary event. You have used this complementary word a lot in your sets. Okay. You know the complementary thing. Let me write here only. Complementary. That is, you can write it as a dash. So what is the what is the complementary event means? See, whenever you have this complementary event, I hope you know the a dash thing. So in the set also we have universal set, we have a set. So a dash is going to be universal minus a. So whatever the set a has, you have to remove that, and whatever the things which are left in that universal set, that is known as the complementary set. Same way here we have some, suppose we have the probability of set a, that is, suppose we have the probability of set a, sorry, of event a. Okay, that is p of a. So that is the probability of event a. Should we take notes? See, this depends upon you, because I advise you to write, okay, to write all the terms, because you know right now you must be thinking that these are the some simple terms and you even know the meaning. But when you come across the questions and there are a lot of terms, and actually the question is designed in such a way that you are not being able to understand that question in one flow. So when you are, you know, when you are friendly with all these terms, the question makes you easy. Okay. See, this is simple thing. When you are friendly with something, you are being able to understand that thing very easily. So I advise you guys to just write everything, no, like, and I advise you to just not make notes long, lengthy notes. Okay, just make it into 2-3 pages, divide the pages into two, make it into 2 or 3 pages, not just long notes, because if you make long notes, it's going to take a lot of time. Okay, and when you are in a hurry and when you are needing to revise that chapter, you need to revise it in a quick way. So for a quick way, you need to make the notes in a shorter and in a perfect way. That is going to be the efficient notes. Okay, so for making the notes, you should write it on your own. You should not take screenshots. Obviously, if you are somewhere else and if you're not being able to use the copy pen, then you can take screenshots and make it to the other side, that maybe sometime else you will write the thing in your copy. But I would suggest write it with a copy and pen. Okay, and just make it to 2 or 3 pages. Just don't exceed any chapters notes more than 3 pages. Okay, it's not going to be any use of you if you're going to make long or lengthy notes. Okay, so this is my advice for the notes. Okay, now probability of event a, that is the pa. Now complementary event, talking about that, that means that 1 is the total probability of any event, that is 1. Okay, so 1 minus p of a, that is going to be the complementary event. Okay, I hope this is being clear to you all. What does this complementary mean here? Okay, now what else do we have here is, just a second. So complementary event done. Now talking about impossible event, we have more other terms. We have here is impossible event. Impossible event, as the name suggests, it is something which is we are talking about that probability is going to be 0, because that is never going to happen. Impossible event, the probability of that event is going to be 0. Okay, that is the like, that is known as the impossible event. Now talking about more, that is the sure event. Sure event is something that is surely going to be happen. Okay, sure event is something that is surely going to happen. So that means the probability of that event is obviously going to be 1. When something is sure, that means the probability is 1. The total probability, that is 1. Okay, now talking about the mutually exclusive events. Mutually, see, you have these terms as exclusive, exhaustive, and when you don't know these terms and when these terms comes in the question, then you don't know how you are going to relate those terms. Okay, you don't know what is the relation, then how can you be able to solve that question? So because to make those questions easy for you, these are all the terms which I am using right now, because after this we are going to do a lot of questions. Okay, so in those questions we are going to use those terms of exhaustive and exclusive. So at that moment of time you don't need to think that what does this exhaustive or exclusive mean. That is why I'm just defining every event, every term right now. So just pay attention here and keep on making the notes or anything, so that you don't need to look back while solving the question. You already know all the answers. Okay, so now you are talking about the mutually exclusive event. Okay, mutually exclusive event, something that is means as disjoint. You can also write it as to make it rememberable, you can write it as disjoint. Okay, so what does it mean? As suppose A and B are the events, so what does it mean? Writing the definition, A intersection B is going to be phi. That is, there is no intersection of A and B. Okay, like these, if A and B are said to be mutually exclusive, that means that A intersection B is going to be null. That is, they cannot occur together. Okay, what does it mean? As that A and B events cannot occur together. Okay, that is the meaning of mutually exclusive. Okay, exclusive means disjoint. That means A intersection B nothing. That means A and B are never going to happen together. Exclusive means exclusive, excluding. A is excluding everything. Okay, A and B are going to be very, A and B are going to be different events, and the intersection of them is going to give you null result, and they cannot occur together. Now talking about the exhaustive events, we have here is exhaustive. So exhaustive even means exhausting. Okay, so exhaustive, as the word suggests, it means that if A and B are exhaustive events, okay, then A and B is equals to sample space. Okay, that means A and B, A union B, A and B, combining A and B, that will be equal to sample space. Exhaustive, that means they are see, exhaustive, you just assume it's going to be the universe. You suggest A and B are the events, and A and B is the whole universe, so A and B is going to be the sample space. Okay, now how do we write this thing? A and B gives us S. Okay, how is the flow of this class going to look like? See, the flow of this class is going to look like, firstly, we will do all the theory. I'll tell you all the events, I'll tell you all the theorems, I'll tell you all types of probabilities, conditional probabilities, Bayes theorem, and the graphical also probability that we know as NP, NPQ, and telling you about all these things, Bernoulli's conditions also. And then we will do the last year question. So that is how the flow is going to look like of today's class. Firstly, we will do the theory, complete the probability chapter. I assume that I am going to give you a one short webinar of this probability. So by studying this, you can start doing your JEE past year questions. Okay, there should nothing be left you need to study for doing that question. All you need to do is just practice completing all the theory and then making you do the last year JEE questions, so that you can be confident enough to start doing questions on your own. Okay, covering all the theory and then doing the questions. This is the flow of this class, in case of anyone wants to know that how is this class going to look like. Okay, now telling you about the exhaustive events, done here. Now some more terms still left here. Okay, now we have this equally likely. Okay, equally likely, I tell you what, equally likely, the probability is same, means the event are favorable enough. Okay, A and B are said to be equally likely if the events are favorable enough, if the events probability is same. That means if you toss a coin, the probability of head and the probability of tail is going to be same, exactly same, right? That is why we say that the probability that is why we say that these events are equally likely. How you can I'll just write here the example so that you can remember. Equally likely means, for example, you can write here, when you toss a coin, head and tail here. Okay, head or tail. Okay, Now, talk more about terms and all. Now we will talk about something else. Terms done. Now what do you need to do? You need to scan the code and get yourself added to our Telegram channel. It's free of cost, and you will get to the access of our PDF materials, free classes, announcements, discounts and prices. See, scan the code, and whenever you have this webinar, we can notify you that this is the topic of today's webinar and you can attend that. We will provide you PDF material there. You can get access to that PDF materials there. Okay, you can get notifications about our free classes. You can get the announcements of all the giveaways and prizes and everything which is going on in Altedemy. And you are already becoming the member of our family, so get yourself added to our Telegram channel as soon as possible. Right now, scan the code. Okay. Now terms, we already talked more about terms. Now what else do we need? I'll just write some formulas. Okay. So I already told you, whenever we need to find the complementary thing, when for example we need to find the probability of E dash, that is the complementary of that event is going to occur, then that example is going to look like 1 minus P of E. Okay, so that is done. Now I'll talk about conditional probability. Okay, before conditional probability, one thing else is left, that is the independent events. Independent event means that the event is not dependent upon the other event. Okay, let me write this thing. Independent event means that the occurrence of one event is not going to is not going to affect the occurrence of another event. And what is the mathematical notation of this? The mathematical notation of this is that P probability of A intersection B is equals to probability of A into probability of B. Okay, what does it mean? That the event occurrence does not affect the occurrence of another event. Each other. Try to write occurrence. Okay, so this is the mathematical notation whenever it is given in the question that this and this event are independent. Okay, whenever this thing, how it is going to be used, whenever you have this thing that these events are given to be independent, what you're gonna write straightly, you're gonna write this thing that P probability of A intersection B is equals to probability of A into probability of B. Simple thing. This is how you're gonna make use of all these terms which I am teaching you right now. All these things are going to be used in the question. Okay, the probability and permutation combination is something for which you cannot skip the theory. One thing you skipped and that thing comes in the question, the whole question gets ruined. Okay, so never skip the theory in probability and permutation and combination, because these are the questions at which the basics are very important. Okay, the basic events, the basic terms are required to be understood. Okay, and if you don't know the meaning of independent event, then how are you going to solve the question? You're going to think that if you don't know that probability of A intersection B is equals to probability of A into probability of B, when you have given that these are the independent events, when you can't apply this much thing, then how are you going to be solve the question? You are not being able to solve the question after that. Okay, so for all these things, you're going to make the notes, you're going to remember all these terms, and that is why you're going to solve all those questions easily. Okay, now these were the events which I told you. Now we will talk about the conditional probability. Conditional probability is very important. See, there are three types of question probability that is being asked. Okay, one comes for conditional probability, one comes from Bayes theorem, and one comes from that NPQ that takes from the graph thing. Okay, when we have the statistical data and you calculate the probability of success, you calculate the probability of failure. Okay, from there you can find out the question. So there are three types of question that comes, and that is in your destiny, that whichever type of question comes, you need to practice all those types of questions. Okay, so conditional probability, what does it mean? That probability when a condition is given. Okay, see, for example, when I tell you that one red ball has been picked from the bag and another ball is being picked, so this is the conditional probability that we have been given this condition that one red ball has already been picked, and now we are talking about the second ball. Okay, from there we get to think that okay, conditional probability is being used here. When you have this question that one ball has been drawn from the bag Now we are drawing the second ball. What is the probability that the second ball is going to be red? So that is going to be the conditional probability. And how do we write this thing? How do we write this thing? For example, we have this probability P, probability of A, this. Okay. How do you write this? Like, what does it mean? That B condition has occurred. B is the condition that has occurred, and now we are calculating the probability of A. This is how we write this probability of A when condition B has occurred. So here B is the condition which has occurred. Okay. How do you write this thing? You write this thing, again I'm telling you, B is the condition and you have to find the probability of A. Okay. And what is the formula for this? The formula for this is probability of A intersection B and probability of B. So B is the condition that has already been occurred. So we have to find that probability, and for the shortcut, for the remembrance of this formula, just remember whichever term is in the denominator, that is going to be the denominator. That's probability is going to be in the denominator. So are you going to remember this? Probability of A when condition B has occurred, probability of intersection B, both the events intersection, and in the denominator we write probability of B. Okay, done. Now what else do we have here is, what else we can write here? For example, we have all these formulas. We can make these formulas from this conditional probability, that is A union B, and F is the condition that has occurred. So how you can write it as? You can write it as simple thing, that is probability of A union B intersection F. Okay, probability of F. And what else we can write here? We have this another formula, that is probability of A with condition F, probability of B with condition F, minus probability of A intersection B with condition F. Okay. From where this formula came? I hope most of you are being able to make out that from where this formula has came. See, you know the formula of A union B, that is A plus B minus A intersection F. Okay. Same way here we have used this thing, that is A plus B minus A intersection. Okay. So this is the formula which is being used here. Okay. Now we have this conditional probability that is being covered here, and conditional probability done. Now what else we have here is, when we will do question, right now I have explained you what is conditional probability, and now I'm going to tell you about Bayes theorem, then the graph, and then we are going to start the questions. Okay, so conditional probability done. Subscribe to the YouTube channel right now, guys, because just subscribe to the channel, it gives us motivation, it gives us support that you guys are watching us, you guys are liking this channel. So if any one of you has liked this channel, just subscribe to our channel and let us know that how you guys liking us, like how you are feeling, and what else do we need to do to make you guys, being able to help you out more. So just subscribe to the channel right now, guys. Okay, now talking about the Bayes theorem. Bayes theorem is something which is mostly asked, law of, okay, let's just say multiplication theorem, and then we will talk about the law of total Bayes theorem. Okay, multiplication theorem is somewhat same with Bayes theorem. So firstly I'll tell you about the law of total probability, and then Bayes theorem. Okay, same thing, multiplication theorem, same thing. Okay, now I'm going to tell you about the law of total probability. See, if we are given that the event, there are so many events that is being occurred, okay, and we have a lot of events that is being occurred, and we have their probability that P of E1, P of E2, P of E3, we have all these events of E1, E2 till En. Okay, so now when we have to find out the law of total probability, what does it say is, the law of total probability states that the probability of event A is equals to probability of event E1 into probability of A when the condition of E1 plus probability of E2 into probability of A with the condition E2, and that is being followed till the event of En. Okay, that is what the law of total probability states. When there are any event that is being occurred and we have to find the probability of A, this is how we are going to solve the law of total probability theorem. Okay, this is the theorem, that is what it states. In case of remembrance, you already know, I have already told you, see, this thing and this thing, the denominator and this thing is going to be same. For example, you can just remember it, that what is left here is probability of A. So that is how you can remember that formula. You can just make it in your mind. And already you know the definition of multiplication theorem. Multiplication theorem, no, you don't know. Firstly, I'll cover the base theorem, then we will go with the multiplication theorem. That will be easier to understand, okay? So base theorem states that whenever you have to find out some event, when you have number of events being occurred, so what is the probability of that event being occurred in that number of events? So how you calculate that thing? Base theorem. Suppose we have here is, let E1, E2, En, okay, these are the events, and we have A, that is the event that has already occurred, okay? I told you in the law of total probability also, okay? So now when you have to find out the probability of any, suppose we have P of E of 3, you have to find the probability of event 3 when A has already occurred. So how you can find it out? See, for the shortcut, for the remembrance of the formula, simple thing you can do is, you can just write the opposite of this into P of E3, and what else you can do? Just write the whole denominator, the total probability, okay? That is, it is going to happen till the event En, okay? Okay. This is how the base theorem looks like. In the denominator, you have all the sample space. In the denominator, you have all the sample. See, Ayush Singh is saying, ma'am, Hindi mein padhao. Okay, when I will teach you in Hindi, there is nothing Hindi in probability, first of all. Because the question comes in English, okay? We have English terms in probability. So when you don't know the meaning of English terms, it's only going to harm you guys, okay? So there is no use of studying probability in Hindi. That is why I'm explaining you everything in English. What more I can do is, I can speak slowly, I can go slow, so that you are being able to get friendly with all these terms, because these terms are very important, and these terms are like, you have to know the meaning of these terms to solve the questions. You need to know the meaning of these terms, you need to know all these theorems, okay? So there is no Hindi of these theorems, okay? These are mathematical formulas. See, math concept, I understand. I understand you cannot understand math concept. But what else do you can understand is, you can understand the terms, you can read those terms, you can understand the formulas, guys. Let me show you. See, in this multiplication theorem, even if you don't understand, in this law of total probability, even if you don't understand English, skip. You know this formula, right? I have written the formula. You can know the formula, you can know the law of total probability, then what else do you need? You know the formula now, you can understand very easily that what I'm going to say, what I'm trying to say. Okay. Moreover here also, everything, it is just formula based. What I'm doing is, I'm just explaining you the terms in definition wise and formula wise, so that everything should be crystal clear to you while solving the question. You don't have anything else, okay? You should not have any doubt. So I hope I'm being clear to you, okay? And clearly I'm willing to help you out in every way, but this thing, you should know it in every way. You should know the English meaning of all these terms, okay? That is how you're going to solve the questions. Now, telling about the graphical use, I hope all of you have done some boards question as well. In those boards question also, see, what you know is, N is the number of events, okay? P is the probability of success, and Q is the probability of failure. Now you know that P plus Q is equals to 1, because 1 is a total probability that can occur in an event, okay? You know it. And now when you have known that, you know that Bernoulli's condition also, but you know the binomial distribution questions also come. Okay, that in those three types, binomial distribution problems also come. So how you can write it as, for example, N is the number of trials, okay? And I have already told you that P is the probability of success and Q is the probability of failure, okay? So what you can write here is, you have to find out The mean formula is NP. Remember that, guys. Okay, you know, you need to remember the formula for variance, that is NPQ. Okay, these are very important formulas. When it comes straightforward, you can just strictly find out the success probability and failure probability, and you can easily find out the variance and mean here. Okay, and now when you need to find out something, that probability of that event at R. Okay, R is something that is, you know, at third event, at fourth event. Okay, so when you have X is equals to R, where R is a random variable, so here we can write it as NCR. Okay, R is a random variable here. That is what this formula states. Okay, this is what this formula states. That is the P is the probability of success, Q is the probability of failure. Okay, and R is a random variable that is going to occur. Okay, these are some types of question that is being occurred in JEE. Okay, now we are going to solve the last year questions. What I told you, the recap. See, you need to know the conditional probability, you need to know the Bayes theorem, you need to know about the binomial distribution. Okay, binomial distribution comes a lot. Okay, binomial distribution comes a lot, and it's very easy. But for that, you need to know the binomial theorem concepts also. If you know that NC0 plus NC1 plus NC2 dot 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 is equals to 2 to the power n, this series also. So you need to know the basics of binomial theorems as well. I have covered the binomial theorem chapter, and I hope you have studied from that. Now, covering the theory we have covered. Now we are going to start with the last year questions. We are going to do some questions as well. So without just giving you a brief recap of all our theory. Okay, okay, so let's start doing the question here. We told you about the terms impossible, sure, mutually exclusive. Exclusive means no intersection. Exhaustive means union is equals to being the sample space. Done. Hoping you guys remember the terms. Independent events means A intersection B, A into B. Okay. Conditional probability, hope you remember the formula. Okay. The multiplication, the law of total probability. Multiplication theorem. Multiplication theorem. What is multiplication theorem? Just a second. The multiplication theorem is just, you know, reversing this denominator, transposing the denominator to the numerator, and this into this, some transposition of terms, that is known as the multiplication theorem. This formula is being only required for Bayes theorem as well as multiplication theorem. So for the questions, you need to know one thing and you are being able to solve. You know the probability and failure success, you can do the binomial distribution for questions as well. Okay, now doing one question. I hope you are being able to do this question on your own. So we have this question. This question is of year 2020, 3rd September. Okay. The question says, we have a pair of dice is thrown and sum of dice come up multiple of 4. Then find the probability that at least one dice shows 4. Okay, so here the question says that a pair of dice is thrown and sum of dice, what are the options? One thing more. Okay, the options here says 2 by 7, 4 by 9, 1 by 9 and 5 by 8. Okay, this is the question. Now let's see how you're going to solve this question. We have a pair of dice that is thrown, and that means 2 dice. Okay, and sum of dice comes up to be the multiple of 4. We all know that when 2 dice are thrown, the sample is going to be 36 terms. You know, 6 and 6, and that can be multiplied, and that can be make the form of 36. So the number of terms in sample space is going to be 36. But here what is said is that the pair of dice is thrown and sum of dice comes up multiples of 4. Okay, so that means the sample space is now the sum of terms that is going to be the multiple of 4. Now that cannot be 36, that is going to be less for sure. Then find the probability that at least one dice shows 4. So out of all those sample space, out of all those probability of multiple of 4, you are going to find out that which dice shows 4, the probability of that dice. Okay, so now the sample space is going to be sum of dice comes up to be the multiple of 4. Okay, so what is the sample space? The sample space is going to be 1 3, because 3 plus 1 4, that is multiple of 4. 3 1, 2 6, 4 done, then 4 2s are 8, so 8 6 2 6 6 2, 8, how else it can be possible? 5 and 3, 5 3, 3 5, 2 2, 2 2 is still left, that is 4, 4 4, and 6 6. Okay, 1 2 3 4 5 6 7 8 9. That is the number of ways the terms can be the multiple of 4. That is 3 1, it is possible that in one dice it is 3 or another dice it is 3. So 3 1 1 3, 2 6 6 2, 5 3 3 5, 2 2 2 2 2 is same, 4 4 same, 6 6 same term, same thing. Okay, so now in the sample space we have 9 terms. Okay, so simply just see these options. Okay, now we should be smart enough to eliminate the options. What is our purpose? The purpose is to do the question. That is it? No. The purpose is to do the question in a very quick way. Okay. So we have here a sample space 9. So is it possible 2 by 7? No. Is it possible 5 by 8? No. So obviously one option is going to be from 4 by 9 or 1 by 9. Now find the probability that at least one dice shows 4. So one dice shows 4. So in which event 4 is being occurred? There is only one. 4 and 4. So what is the probability going to look like? That is going to be 1 by 9. So what is the correct answer here? 1 by 9 is a correct answer. You understand what this question was trying to say? This is like binomial expansion. Yes, are you talking about that binomial distribution thing? And that is why it is named as binomial distribution, because it is similar to the binomial expansion. And when you are being friendly with the binomial expansion, then you can easily solve those questions, because you need to know some formulas of combination as well to solve those questions. I hope this question was clear enough to you all. Any one of you who is having any difficulty in this question, just comment down right now. I'll solve the question again. Okay, now let's just do another question. Okay, this question is tricky enough. Like this question tests your basics. Okay, you can use the example, you can use the diagrams help. Okay, I'll just write the question. The question says that let A and B be two events such that the probability. Okay, and this question is from 8th Jan 2020. Let A and B be two events such that the probability that exactly one of them occurs is 2 by 5, and the probability that A or B occurs is 1 by 2. Then the probability of both of the, I suppose, events they are trying to say occur together. Then it is asked. Okay, and we have these options, that is 0 0.02, 0 0.20, 0.01, 0.10. Okay. Okay. So what is the question saying? Let's just read the question. Let A and B be two events. Okay, two events such that the probability that exactly one of them occurs may be A or maybe B. Okay. One event is going to occur, that is for sure, but we don't know if it is talking about A or if it is talking about B. That is 2 by 5. And probability that A or B occurs is 1 by 2. Then the probability of both of the occur together. So what it is asked, firstly let's just focus on what is asked. So probability of both, that means A intersection B is being asked. Okay, that both the probabilities is being occurred, so that means both occurrence, and both when it comes both in the intersection. Okay, and this is given probability that A or B, whenever we have A or B, we know it is talking about the union. Okay, so now we have probability of A union B is 1 by 2, because we are talking about A or B, so that means it can be anything. So P in A union B, and here what is said, let A and B be two event such that exactly one of them occurs. Now here we take the example of diagram. See, for example, we have here is probability of A, we have here is probability of B. Okay, so here what we can do, exactly one of them occurs. So when exactly one of them, that means it is talking about this. Okay, it is talking about this, or it is talking about this. Okay, if it is talking about this or if it is talking about this, that means this intersection is not being excluded. Let me use another color. That means this is not included, this is excluded part. Okay, so how it can be find out? See, it is included in A also, it is included in B also, and it is being occurred exactly in one. So how you can find it out? You can find it out how you can write it in mathematic way, that what is this 2 by 5? We can write it as probability of A plus probability of B minus, because it is two times, in probability of A also, in probability of B also it is getting included. So here we will use two times of probability of A intersection B, because we have to subtract this thing. Okay, we have to subtract this thing. When we subtract this from probability of B, we find out this area. Okay, but in this also it is included, so we have to subtract from this also. So how it is calculated? It is calculated probability of A plus probability of B minus 2 times of intersection of B. Okay, so this is what it is given in the question. Now if you know the diagram, if your basics were clear, then you can easily write it that this is what it means, and now you can easily solve. So what it is given? It is given as 2 by 5 here, and you know the formula for A union B, that is probability of A plus probability of B minus probability of A intersection B is equals to 1 by 2. Okay, is equals to 1 by 2. Now what you need to find it? A intersection B. Can you guys find it out? Can you guys find it out? See, I'll just find, we have this equation 1, we have this equation 2. I'll just find it out for you all. So probability of A plus B, we have to find A intersection B. So we can just equate the terms in that way. So we can get the value of probability of A plus B is equals to 2 by 5 plus 2 times of probability of A intersection B. Is it clear? We just solved this equation. Okay, we just transport some terms. And now we are using equation 2 here. Okay, probability of A plus B, it is given like this. We can just write it as 2 by 5 plus 2 times probability of A intersection B minus probability of A intersection B is equals to 1 by 2. Is it clear? We just equated this thing in this. Okay, now we got this 2 by 5 plus 2, 2, 2, 2, 2, 2. So what we got here is writing it here. Okay, look here. So we have probability of A intersection B is equals to 1 by 2 minus 2 by 5. So what do we have here is 0.5 minus, so what is the answer? This is the answer. We got the answer. So was it difficult? See, all you needed to know was to find out that in which mathematical terms these values are given, and how you can find it out by going through the theory. So that is why I was saying that theory is important in probability and permutation and combination, because if you don't know what is this question saying, okay, Ashrita is saying to explain it again. See, first of all, it's an easy question. Okay, it's an easy question. Don't like just stress it out. What we have given here is, let A and B be two events. There are two events, A and B, that exactly one of them occurs. And here it is given one of them occurs. That means intersection cannot happen, because intersection means that B is also happening in that thing. So we have to find out only that thing in which one event is going to occur. So that means it can be either, let me take another pen example. So that means either this area or either this area. Okay, so how you can find out this or this? You need to subtract the intersection area for this if it is occurring in event A, then we have to subtract A intersection B. Okay, probability of A minus probability of A intersection B, plus it can also occur in probability of B also, but only in B. So we have to subtract that A intersection B. So we have to calculate plus probability of B minus probability of A intersection B. So what does it becomes? Probability of A plus probability of B minus 2 times of minus 2 times of probability of A intersection B. What is the value given? 2 by 5. We have this equation. Done. What else it is given? That A or B occurs. A or B. A or B means A union B. Okay. Easily you can just assume when it is given A or B, it means A union B. Okay. A union B is given 1 by 2. Now you know the formula of A union B, that is in set also. I have written in this there the formula, that is probability of A plus probability of B minus probability of A intersection B. So that is equals to 1 by 2. Now we have two equations here, and you have to find out the probability of A intersection B. So what did? I just calculated A plus B, probability of A plus B in term of A intersection B. Okay, just substitution method. I just do the substitution method to solve the simultaneous equation, and just substituted this value in equation 2. I substituted the value in equation 2. This is the equation 2. Just solve this value, and here this is the algebraic thing. We know 1 by 2, that is 0.5. We know 2 by 5, that is 0.4, and we got the value of 0.1. Is it clear now? I've explained it again. Okay, so I hope this is clear to you all. So let's just quickly do one more question here. Okay, okay, let's just do one Bayes theorem question. Bayes theorem questions are very lengthy, I tell you, but these questions are so easy, guys. All you need to do is just you need to understand that Bayes theorem is being applied here, and if you are being able to make out that okay, this is the question of Bayes theorem, question is done. I tell you, the question looks lengthy, but the question is too easy. So I'll just write the question in a very fast way because the question looks lengthy. So we have this thing, box 1 contains 30 cards numbered 1 to 30, and box 2 contains 20 cards numbered 31 to 50. A box is selected at random and a card is drawn from it. The number on the card is found to be a non-prime number. The probability that the card So we have this question. Box 1 contains 30 cards number 1 to 30. 2 contains 20 cards number 31 to 50. A box is selected at random and a card is drawn. So there are two events that are second. First we have to select the box. There are two boxes. Okay. Selection of the box, then selection of the card. Remembering this. The number on the card is found to be a non-prime number. So the number is found to be a non-prime number. That means the number is not prime. The probability that the card was drawn from box 1. So box 1, that is going to be the favorable event out of box 1 and box 2. And we have to find out that the number of card is found to be a non-prime number. So non-prime number's probability is going to be the favorable probability. Okay. So now what is going to be the, see, there are two box. The probability is going to be 1 by 2. The box probability, if it is going to be box 1, that is going to be 1 by 2. Probability of box 2, same thing. 2 box 1 by 2. Okay. Now we have what are the prime numbers which are in the cards? We have 2, 3, 5, 7, 11, 13. Number 1 to 13. Okay. 11, 13, 17, 19, 23, 29. Okay. So out of 1 to 30, these are the prime numbers in the box 1. Okay. Now a box is selected and a random and a card is drawn from it. This is given. The number on the card is found to be a non-prime number. Non-prime number. That the probability that the card was drawn from box 1. So we have to find out the card was drawn from box 1. That is why we calculated that these are the prime numbers in box 1. Okay, these are the numbers in box 1. So what are the numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here we have 10 prime numbers. Okay, in box 1. So that is 10 prime numbers. 10 prime numbers. The number on the card is found to be a non-prime number. But what is the favorability? That is non-prime. So what is going to be the non-prime probability? That is going to be 30 minus 10. Okay. So 30 minus 10, that is the non-prime. That is 20. Okay. So what is the probability that the card was drawn from box 1? That is going to be 20 by 30, because these are the total number of cards. What is the box 1 probability? That is 1 by 2 here. And what else it can be? I hope it is visible. I think it is not visible. Maybe I will be coming in the way. Okay, let me write it in small. So box 1 probability is favorable and the non-prime number is favorable. So we have 20 by 30 into 1 by 2. 1 by 2 into 20 by 30. What else it can be? It can be from box 2 also. Okay. So box 2 also. So we have 1 by 2 into, what do we have here is 31 to 50. That means 20 cards. And out of 20 cards, we know that 15 numbers are going to be the non-prime numbers. So from 31 to 50, similarly, like this, we calculated the prime numbers. Similarly, you can do from 31 to 50. I am telling you that 15 are the non-prime numbers. So this is how you can solve this question. Okay. Now, is it clear to you? I can solve it algebraically also. See, 1 by 2 is taken common. We can just easily remove it and you can just solve it algebraically. So there is nothing left to be solved algebraically here. You can solve it. It is a very easy thing. I am just revising you the concept, how I did this thing. So what was asked was that box 1 contained 30 cards, numbered 1 to 30. Okay. Box 2 contains 20 cards. See, we have, I'll just draw some diagrams here. We have box 1, that is 1 to 30. Okay. We have box 2, that is 31 to 50. Okay. These were the cards. A box is selected at a random. Okay. Now box is selected So box is selected, selection of box from any, like selection of one box from out of two, what it can be, 1 by 2, that is going to probability. What it is asked, number on the card is found to be a non-prime number. Number of the card is found to be a non-prime number. So non-prime number probability, and it is said that the what it is asked, the question that is asked is that the card was from box 1. Okay, so non-prime numbers probability from box 1, from box 1, or what else, non-prime number, that is this is the favorable. Okay, and what else, it can be that non-prime number from box 2. Okay, so from box 1, how do you calculate non-prime number? Simply find out the prime numbers here. Okay, we calculated the prime number from box 1. These were the numbers, they were 10 prime numbers. Okay, we calculated they were 10 prime numbers, and on total they were 30 numbers. So 30 minus 10, that is going to be the non-prime numbers. So what is the probability going to be? That this is going to be the non-prime number. The probability is going to be from box 1. The probability is going to be 20 by 30, because 30 is the total number of cards, into 1 by 2, because from box 1. Similarly, now non-prime numbers from box 2. So I already told you we have 15 non-prime numbers, but here I am going to write it again. So what were the numbers here? 31, 33, 39, 41, 43, 47. Okay, what else we have here is, here we had 15, that means only 5 were supposed to be here. So I think there happened to be a mistake in the numbers. Oh shit, I'm sorry, I just by mistake erased all the ink strokes on the slide. So I hope that was clear to you, the numbers. Okay, so I already did you the favorable probability. Similarly, we calculated this probability as well. Yeah. I assumed. I just wrote two numbers which were not included in those. So that was 33 was not included, and one number else was included there. Yeah, I understood. So because the time is running out, so I was just hurrying. So there were two numbers that should not be included. So that excluding those two, we got 15 by 20. So by solving this, we can just easily solve this algebraically. See, 1 by 2, 1 by 2 is getting cancelled out. Now we have this 20 by 30 upon 20 by 30 plus 15 by 20. You can just simplify as, we have here is 2 by 3 that comes 8 by 17. So I hope this was very clear to you. It was a very easy question. What we needed to just know, that box 1 box 2 thing, that we need to find out box 1's probability as well, because we are choosing one box out of two boxes. Okay, so from there we got this thing. Here we wrote all those numbers, and that number we increased two numbers. So 33 was not supposed to be the prime number, okay, because it comes in the table of 11. Now we have this 15 by 20. So this question is done. So that is it for today's session, guys. I hope you have enjoyed the class, and if you have any problem related to it, you can just let me know in the comment section as well. And if you have liked this video, so just like the video right now and comment on it, share on it. And if you have any advice, any feedback, you can, it's already welcome. You can just let me know. and I hope we will enjoy more and we will do more questions together. So that was it for today, guys. See you soon, and have a good day. Bye bye. Take care.